All right, coming back, we just talked about the destructor or the deconstructor for classes. Now what comes next? Copy over assignment. All right, before we do this, let's go ahead and do another review of pointers. I want to make sure that we at least spend some good time on understanding the differences here. Let's see, special topics, pointers, ODP, perfect. Hopefully this is all going to be a review, and that's perfectly fine. So static is where anything known prior to runtime of your program is stored. So this presentation is going to talk about the different memory. Again, a review of the different memory sections in C++ and where pointers, the exact pointers in C++. This is hopefully a review, but I want to make sure we go through it, and if there's any questions, you ask me again. So I am spending 2 lectures going over this because this is vitally important to understand it. So 3 categories of memory, aka where all your stuff is being stored for your program. Static is anything known prior to runtime, so of course that's your code, and usually any global variables are placed there. Your runtime stack is memory associated with functions, aka your stack frames as it moves forward and up and down, and then your heap is anything dynamically allocated. Every time you do a new, it's on the heap, otherwise it's on the stack, or global. So static is the simplest. This is where your code is. Global variables, your constants. Runtime stack, this is a contiguous memory region. What does that mean by contiguous?
Keeps going.
Keeps going. It's always connected. It's contiguous. There's no holes in it. So it just grows down and up, or up and down, depending on how you want to look at it. And it's to support your method calls. So whenever you call a method, it's going to allocate more space on the stack to help with your method calls, because usually you're passing parameters. It shrinks when a method terminates and storage is deallocated. Could that be a C++ class in there?
Yes.
Yes. So I just showed you it can be a C++ class. All right, yeah, local variables, parameters, known at compile time, but the actual content's not known until real runtime. Yep. All right. Heap. Heap objects are allocated, delete, and deallocated dynamically, not with any specific event like function entry or exit, but the event is you explicitly saying allocate memory on the heap, aka you call new. Java and C++ have different policies. Oh yeah, what are the different policies between Java and C++ for heap management?
Java will delete it for you.
What's that?
Java will delete it for you.
And C++ will not. Yeah, that's basically what you need to know. Java will eventually delete all the memory for you, and it's garbage collection. C++, you write the policy. All right. We got malloc and new. Right, malloc new allocated, heap storage, free and delete, deallocated. Y'all didn't do these in procedural, did y'all? No, okay. In C, it's called malloc and free. C++, it's new and delete. So since it's not contiguous, hopefully, it doesn't grow and shrink at the ends, you can see how holes could form inside of memory. All right, C++, you have to do it yourself. A lot of other languages do it for you. Just keep in mind your static area where your code, your globals are is up top, and then your stack is going to grow down with your heap at the bottom. That usually kind of grows up, but it grows and maybe tries to fill in its holes again while you're allocating more memory. And what happens when the stack meets the heap? Sadness. What time? Stack overflow or memory out of memory. Yep, stack overflow. Just said it. All right, a new returns the address of the block of k words used by the heap allocation. I think we went over this pretty well, but let's look down here at point. Point first coordinate equals new point. Calls for, well, it's saying 3 times 4 bytes at least, because we're saying a point is going to have x, y, z, and they're floats. Float is 4 bytes, so it needs to have at least 4 times 3 bytes. bytes of information, or 3 times 4. It'll probably have more in Java because there's more stuff collected with it. In C++, it would have exactly that amount. Maybe a couple of extra things for the operating system, but usually very minimal. Allocated and initialized to some predetermined state, hopefully if you have a constructor that does that for you. Heap overflow when a new occurs and it doesn't have any more blocks to use, aka can't allocate anything. In general, you should test the return of new, although I know all of y'all are not going to, and for this class, I'm going to be okay with that. Delete returns the block of storage to the heap saying you may use this later. Notice that it just says you may use it later. It doesn't go through and zero out that memory. So if you allocate something new over it and start using it, you're using the old values. All right, we're talking about pointers. The value of pointer is the variable is an address, pointing to something else. We're good. All right, here we go. We went through this implicitly with the code. Let's go ahead and look at a nice little chart that I made for y'all. So in Java, you have primitives. The stack example is int a equals 3. The heap example is int array a equals new int of 1. Actually, that's not true. Really, this can't be done. But this is kind of how Java fakes it. It's actually creating an array object that stores one variable on the heap. That doesn't make any sense. Don't worry about it. Classes, Java, creating a class on the stack, you can't do it. Period. But if you want to create a class on the heap, standard string equals new string, I'm a string. All right, C++. Well, you do whatever you want. Primitive, hey, look, it's the same thing. Heap, notice it's a little different. You're not creating an array, you're just creating a pointer and calling new int. So you're creating one integer on the heap. Class, notice I'm just calling string str, I'm a string. Notice that since there's no star in front of str, it's not a pointer. It's just allocating directly on the heap. And then lastly, this is an error because there should be a star in front of str equals new string. Any questions about this? We're good? Hopefully I'm beating the dead horse. Java arrays are always allocated dynamically from the heap. In many other language, global defined arrays are static, local are on stack, and dynamic is on the heap. All right. I think we talked about this a little. Java or C++ allows you to do it either way. But what's the difference here? What's the difference between the first two and the third, aka this guy and this guy versus the one down here?
Well, the first two are at the bottom of the stack, and the third is the
There we go. Just trying to make sure it's clear. Notice this is creating a two-dimensional array on the stack. No problem. And in Java, you had to make everything on the heap. All right, we talked about that. Java does garbage collection. All right, we're good. Any questions about that? All right, quick review. Hopefully that was clear. If not, please come and talk to me during office hours.